Hi there. Let's look at some past paper questions on composite functions, or on sets of functions I should say. So example 1a, we've got f of x and g of x, and we have expressions for that. So I want to find an expression for f of g of x. So that means we just take g and put it into f. So I can say that f of g of x is going to be x plus 4 whole squared plus 3, because I want to take this x plus 4 value, and because g of x is on the inside, it goes inside the outside function, which is f. Let's expand those brackets. So that gives me x plus 4 times x plus 4 close bracket plus 3. Expand the brackets so we get x squared plus 8x plus 16 plus 3, which gives me x squared plus 8x plus 19. G of f of x is the opposite process. We take x squared plus 3, which is f, and sub it into function g where we see x. So that's just going to give me x squared plus 3 plus 4, which is x squared plus 7. So here I have an expression for f of g of x and g of f of x. This will now help us to find the answer to part B. In part B it says, show that f of g of x plus g of f of x equals 0 has got no real roots. So that phrase there, no real roots, should be familiar to you from National 5 quadratics. We'll deal with that in a second. Let's bring together f of g of x and g of f of x. So f of g of x is x squared plus 8x plus 19, and I want to add my g of f of x, which is x squared plus 7, and set it equal to 0. So that gives me 2x squared plus 8x plus 26 is equal to 0 when I simplify it. So what I want to do here now is I want to show that this has got no real roots. So think back to National 5 quadratics. When do no real roots occur? Well, we have no real roots when b squared minus 4ac is less than 0. If you don't remember that, then it is a good idea to go back and recall your National 5 quadratics notes, because this is one of the key topics that you really need to be pretty good at in order to cope with higher mathematics. So let's plot the values of a, b and c. So a is 2, b is 8, c is 26. So put the values in, so we get 8 squared minus 4 times 2 times 26 is less than 0. Okay, so let's work that out then. So just the usual, 8 squared will give me 64. And then I want to work out minus 4 times 2 times 26, which is going to give me minus 208. Now, I want to work out that, which is going to give me minus 144. Now, I really shouldn't have put in the less than 0 there, because we're not working out an inequality solution here. We're just finding the value. So it's 8 squared minus 4 times 2 times 26, which when we work out we get minus 144. Minus 144 is less than 0, so because our discriminant is less than 0, that is the proof that f of g of x plus g of f of x equals 0, has got no real roots. So let's put all that together then. Remember, it's a show that question, so it should really finish off with a sentence at the end. So we can say, therefore, since b squared minus 4ac is less than 0, f of g of x plus g of f of x equals 0 has no real roots. And that's it. Final past paper example. Past paper example number 2. It says functions f and g are defined on the set of real numbers. The inverse functions f to the minus 1 and g to the minus 1 both exist. Given that f of x is equal to 3x plus 5, find f to the minus 1 of x. So we'll change our f of x to a y. So we'll say that y is equal to 3x plus 5. And change subject to the formula. So we get y minus 5 is equal to 3x. Divide both sides by 3. So we get x is equal to y minus 5 all over 3. F to the minus 1 of x is equal to x minus 5 all over 3. Don't forget, when you do your inverse functions, you must change your x into your inverse notation and your y's back into the x's. Part B here, it says if g of 2 is equal to 7, write down the value of g to the minus 1 of 7. Okay, so we've dealt with and getting practice on changing between the inverse function f into f to the minus 1 of x. Now looking at the function g of x, what I've got here is I've got some value of 2 that when I apply the function g of x to it, the result is 7. So if I apply the function g of x to 2, the result is 7. This question here is saying write down the value of g to the minus 1 of 7. So remember, g to the minus 1 is the inverse function, and the inverse function is just the reverse process of the original function. So going back the way, if g of x goes from the domain D to the range R, then the inverse function goes back the way from the range R to the domain D. So g to the minus 1 of x, if g to the minus 1 of x is 7, then the result of putting 7 into the inverse function takes us all the way back to 2. So therefore I can say that g to the minus 1 of 7 is equal to 2. It's just the reverse process. That is the end of the first chapter of Higher Mathematics on sets and functions.